Hi guys. So this video is meant to teach you how to organize your data and how to create graphs and how to analyze graphs and things specifically for our first lab. If you didn't already set up your data in this way on your Google Sheets, please do that. Pause this video and do that now, and then you can resume when you finish. So at this point, you want to convert your grams into kilograms in this column, right? So remember that to convert from grams to kilograms, you want to divide your gram value by 1,000. So to activate the calculator part of Google Sheets, you hit the Enter key, reference this cell because we want to divide this by 1,000, and literally type in divide by 1,000 and hit Enter. That'll shoot out this value, which is what we expect. And we also talked about how you can repeat this same function, right, for all the rest of these by double-clicking the bottom right corner here. That way, it does the exact same thing. This is A3, this guy, divided by 1,000. This is A4 over 1,000, right? This is A5 over 1,000, so on and so forth until the ending. Now with the weight, you want to go from kilograms to newtons. So hit the Enter key, reference this cell now, and multiply by 9.81. Hit Enter. And do the same thing again. You can either drag it from the bottom right corner, or you can just double click it. Either way works. Just make sure that you're clicking on that cell first and then doing those things, either double clicking the bottom right corner or dragging it downwards. And now that's all your weights in newtons. Now your elongation in meters, you already have your elongation in centimeters, so you want to divide that value by 100. So equal sign. You want to reference this cell, B2, and divide it by 100. Enter. And then now you do the same thing here where you double click the bottom right corner. And there's all your data. Now you can of course customize this and put borders on it by clicking this button, or highlight or whatever you want to these cells to make it look nice for your lab report. But I'm gonna let you do that in your own time. We need to make a graph. So I'm gonna click on Insert and then Chart. And then by default, for some reason, it gives us a bar graph, right? You see from this little icon here. But we're never going to make bar graphs. We're always going to be scatter plots. So we're going to scroll down here and then click on Scatter. And now we choose our data points, right? So under X-axis, you click on this grid here, where it's going to allow you to select what your X values are going to be. Our X values are whatever that we have control over in the experiment, what we have direct control over, what we can manipulate. In this case, we were physically adding more weight onto the bottom, onto the mass hanger. So our weight is going to be our X-axis values, right? Now we said in class that you want to also highlight the word weight when you're selecting your X values because it might label something for you later on, which is great. Press OK. Now series is your Y values. So you click on series over here on the grid, same thing as before. And now you put all our Y values. In this case, what changed as a result of our weight was the elongation of the spring. So we're going to click and hold this elongation all the way down until we get all our data points, including the title, what we titled it elongation, and hit OK. Now there's all of our data. Okay. Now we want to do more with this because the whole idea behind graphing this is that we want to find the slope, right? But even before we do that, we notice there's some stuff missing about the graph. We need to add a chart title and axes labels. So you go to Customize, and then you hit Chart and Axis Titles. And notice over here, the first thing it gave me was Vertical Axis Title. So click on this part, and then I'll type in whatever I want my vertical axis to say. In this case, our Y variable, our dependent variable was the elongation. So I'm going to type in elongation and meters. Make sure you include our units as you're labeling these. Okay, and you click this now to choose what else you want to label, right? You notice in here the graph is already labeled now. Horizontal, let's do horizontal. Now horizontal is what we had control over. In this case, it was the weight. So I'm going to type here weight in newtons. Oops, newtons. Sweet. Now you notice it's written on here. We now want to do our chart title. Okay. A good title for any graph you ever make is always your Y value versus your X value. So I'm going to do elongation versus weight. You can also make it a little fancier by typing in elongation of the spring versus weight hung, or the effect of the weight on the spring on the elongation of the spring. Either one is fine, but this is perfectly fine. So now we have all this stuff labeled. We can now do some analysis, right? So let's do that. So we scroll down to where it says series. Series just allows you to format things about the data, right? So our data points, we can change their color. We can change the point sizes, what kind of shapes these are. We're going to leave all this stuff blank because that's not important for science. And then down here is trend line. Now you've learned in chemistry the idea about best fit lines. This is that. Trend line is the exact same thing as a best fit line. So you click on that to make it checked, and then you notice the best fit line shows up. Now, based on our data, it looks very linear, right? It looks very linear, which is why we're going to make a linear fit. And also the reason why this lab is called simple linear measurement. And so you're going to make it say linear. You can also choose later in the year as these different functions, but for this lab, it's definitely going to be a linear trend. But we want the equation of this best fit line. So under label, you click it, and then you click on use equation. So there is our equation of this line. Okay, so what we find though is that this slope, right, this is in y is equal to mx plus b form, where m, our slope, is 0.0669, our y-intercept is negative 7.78 times 10 to the negative 5. Remember, this e to the minus 0.5 means times 10 to the negative 5 power, which is a really small value, which makes sense because if you look at our graph, our best fit line is pretty close to having a y-intercept of 0, right? But we want to analyze something about the slope. We know that the slope of this graph is our elongation versus weight, right? So it's elongation over weight. But based on our notes we took in class on our first day we did this lab, we're looking for weight over elongation. And so if this is the slope of elongation over weight, we want to inverse this. We want to flip this value over to find what our spring constant is. Okay? And also, if you look at the units of this, the slope of this has units of meters, rise, over run, newtons, meters per newton. But spring constants have units of newtons per meter. That's also another indication that tells us that we need to flip this slope. So this slope here is 0.0669. So you want to find the inverse of it. I'm just going to do this small calculation over here. So it's equals, again, to activate the calculator, 1 divided by, because we want to inverse it, 0.0669. Enter. That's my spring constant. My spring constant for my data was 14.947 or 14.95 newtons per meter. Newtons/meter, right? Newtons/meter, like that. That's how the unit should be read. And when you write in your lab report, you should include your units. Okay? And that's it for this video. For the next video I'm going to put on, like right after this, I'm going to show you how you're supposed to share the lab report with me.